we're given is the second derivative of a function. And we're going to try to find the function f. And along the way, we're also going to solve for the constants using the fact that it's given that f of 0 is equal to 4 and f prime of 0 equals 12. This is called an initial value problem. So first, we do antiderivative. And our tool is that we're going to use the power rule for antiderivatives. So for negative 2x, the antiderivative is 2x. Why? Because the derivative of negative 2x is negative 2. Then we come to 12, I'll leave that alone. And for x, the antiderivative is x squared over 2. Why? Well, take the derivative of x squared over 2 and you get x. But I come to x squared. I have this exponent 2. What do? I take the 2 and I add 1 and I divide by 2 plus, so 2 plus 1. Even over here, when maybe I should have shown more work. When I got to x, well, you can say that's x to the first power. Then you do 1 plus 1, divide by 1 plus 1. That's the power rule. But as you can see, you would probably want to do that in your head instead of showing all that because it's easy to add, those numbers in your head. So it's pretty, takes up a fair amount of space. And then also I forgot to add plus c, which is super important. So sort of blew it there, but anyway, but I fixed it. Okay, and then I'll just simplify that a little bit. 2x plus 6x squared minus 4x cubed plus c. Now that is f prime of x, but what we're going to do is also we can find c now. Find c, and we're going to use that f prime of 0 is equal to 12. So what I do is I write 12 equals f prime of 0, and wherever I see x, I put in 0. And because those are polynomials, the part with x, it's a polynomial function. Everything when I put in, anyway, as you can see, when I put in 0, everything becomes 0. So I get c equals 12, so therefore f prime of x is equal to 2x plus 6x squared minus 4x cubed plus 12. I think maybe if you do these for a while, you can see that's what's going to happen. But be careful. Just because f prime of 0 equals 12 doesn't mean that c is always equal to 12. It's because of this particular function. But it's going to happen if your original function's your second derivative originally is a polynomial. That's what we're going to see. And we'll just do antiderivative again. So we get f of x equals 2x squared over 2 plus 6x cubed over 3 minus 4x to the 4 over 4 plus 12x. And we shouldn't write c down. We already used c. We should write a different letter, d. Okay, so we, don't use the same letter. Wouldn't really make sense. So f of x equals x squared plus 2x cubed minus x to the 4 plus 12x plus d. And we're going to find d. And the way to do that is we use that f of 0 equals 4. So 4 equals f of 0. Well, everything with x is going to disappear. It's good to show this work. But it's pretty clear that what d is, which is going to be 4. So everything with 0 disappeared. So I didn't write down the right thing, but now I will. So f of x is equal to x squared plus 2x cubed minus x to the 4th plus 12x plus 4. And is that too messy? Maybe it's okay. A little bit. Let's just neaten it up a little bit here. Are they any better? Okay, but anyway. Okay, so there we are. And found the antiderivative of a function where we're given the second derivative and initial conditions, and we found the value of f. All right, that's all.